Yeah, good morning, students. I am Disha Roshan Bhakta, Assistant Professor, Department of Information Technology, Bansanga's SMCT College of Science, Commerce and Management Studies, Powai. So, students, today we are going to continue our discussion on agent types. Our previous session, we have discussed about the very first agent type, which was known as simple reflex agent. So, now how simple reflex agent was working, it was just working onto the current percept, and the working was very simple. It has to just take the current percept, find out in which state it is. After finding the state, it has to find out a rule from a certain set of rules which are already defined, and then after that rule is find out, it simply uses condition action rule and decides which action it needs to follow, okay, depending on this rule. The major point when we talk about simple reflex agent is that it has to just understand the current percept. Okay, none other history of percept is important for simple reflex agent. Now, the next agent types that we are going to study differ from these concept a lot. Okay, so today we are going to study about three different agent types, that is model based reflex agent, goal based agent and utility based agent. All these three agents, okay, just do not work on to the current percept, rather than many other information, or we can say the history of percepts and also many other things are very important for these three kind of agents. Okay, so that's why when we discussed about simple reflex agents, students, we understood that whenever we are in a process of making an agent, our very first motive should be to make it as a simple reflex agent, so that we can very well understand, and then once that is being done, then it can be migrated to a model based agent or a goal based agent or utility based agent, again depending on what is the core functionality of that agent. Okay, so today we'll start with the first agent. Okay, and maybe once we complete the three, we can have a quick we can say a comparative discussion on what all these four agents behave like, and how different approaches they are going to take. Yes, so we'll start with model based reflex agent. The model based agent or the model based reflex agent can work in a partially observable environment and track the situation. Okay, so here a word is coming that is partially observable environment. Fine, so it is one of the characteristics of the task environment, and we already are aware of that either the environment can be fully observable or partially observable. Okay, so when we say fully observable, which means the sensors are able to detect each and everything. Okay, and when the input is very much clear, okay, then again it becomes very much also clear what action needs to be taken. But when the input goes into a partially observable mode, okay, the one thing which happens over here is that certain learning mechanism has to be applied, because the input is not 100% clear. Okay, the input is not crystal clear that okay, something A has happened, so then we have to take action as B. That is not the case. So if that is the environment where certain things may not be observable, then in that case these model based agent can help very well. Okay, that will not be the case with simple reflex agent, because in simple reflex agent the entire working goes onto the current percept, and if the current percept is not known, okay, their behavior will probably fail. Okay, but that will not be the case when we talk about model based agent. Even if they have a partially observable environment, they have certain mechanism into it with the help of which they can understand and they can take certain action. Okay, now there are certain more important things when we talk about model based agent. So a model based agent is going to work on two important factors. Now which are these factors? Okay, so as the name suggests, okay, model, so model is first important factor. Now what exactly model is? It is knowledge about how things happen in the world. Okay, so now, and just let's say taking an example, let's say if we talk about agent, that is a taxi driving agent. Now what is the world for the taxi driving agent? See students, when we say how things happen in the world, okay, when we talk about world, we are basically talking about a bigger picture of environment, for that agent. So let's say if there is a chess playing agent, okay, for chess playing agent, the world is what is the chessboard, what could be the thought process of the opponent opponent player, okay. So that is the world for it, okay. That's what we are trying to tell over here, that it has the knowledge about how things happen in the world. So whenever, again, let's say there is a taxi driving agent, okay, it should be aware about what is the world for it, okay, or how things happen in the world. And the more complex the agent is, okay, so let's say the taxi driving agent, we can tell that it is a very complex agent. So many information are required when the model of that agent has to be created, or when it has to be known, or when the knowledge about how things happen in the world has to be known. So that will basically be first part of model based agent. Second, what does the model based agent require is internal state. Okay, now what is internal state? It is a representation of current state based on percept history. So remember over here that when we talk about model based agent, we are considering the percept history. When we say we are considering percept history, we are trying to tell that whatever previous inputs the agent has got, okay, that matter also to define certain characteristics of the current state. So these two things are going to play an important role when we talk about model based agent: the model itself and the internal state. Okay, so that's the core component of model based agent. Fine. Going forward, these agents have the model, which is the knowledge of the world, and based on the model they perform actions. Okay, so as we have already told that these model based agents will have model. So what is model? Model is nothing but the knowledge of the world in probably in which they are working, and then using this model they are going to decide what actions they have to take. Now, how they are going to define their state, so which is again an important characteristic. Updating the agent state requires information about how the world evolves, how the agent's actions affect the world, the most important part. Okay, again, so let's say if we were talking about simple reflex agent, then the state was just dependent on the current percept. This is the current input, okay, then this is the state. We have to interpret the input, and then the state was being defined. So if we recall the function of simple reflex agent, it was very simple: interpret input. In that interpret input we were having percept, okay, percept to be given, and then what was the outcome? The outcome was state. That is not the case over here. Okay, if we want to know the state, then there are two important things which we need to know. Okay, we need to know how the world evolves, okay, which means we need certain information about the world also. World, again, whenever we are using the terminology world over here, we have to pretty much understand that we are talking about the world for that agent. Okay, the area or the environment in which the agent has to work. How the agent's action affect the world, so that is also very important. Let's say agent decide an action and how that is going to affect the world. Okay, whether it is something which will have a positive impact on the world, or maybe a certain, we can say, opponent effect on the world. So that has to be very much important to know before we understand the agent state. Okay, and yes, these kind of agents are also known as reflex agents with state, because state is very important for them. But state, again, is not just dependent on to the current percept, it is dependent on to the other characteristics of world, and also how agent sections is going to affect the world. So this is a very brief scenario which tells us about how model based agent work like. Okay, so the key points that we have got over here is that it is going to work on a model, which means it is going to have a knowledge about the environment in which it is working. Okay, it is going to also have an knowledge about how the things have evolved into that environment. It will also have a knowledge about, okay, what if these actions are being taken by me, what is going to happen to the world. Okay, so considering all these points, okay, the condition action rule is going to work. So over here also, finally, these agent also has to take an action. Okay, no matter whatever the agent is going to take input and has to give output. That is going to be fixed. Maybe it is simple model or anyone. Okay, but then after taking the input, what other parameters are going to be considered differs from agents to agents. So when it was simple reflex agent, none other parameter was considered. Okay, just taken the input, directly going to the condition table, finding what action to be taken, and the action was thrown back to the environment. That will not be the case over here. Okay, after interpreting the input, there will be multiple processes which will be going on into the model based agents, and afterwards only it will go to the condition action table, or maybe the condition action set of rules, and from there then again it will decide what action has to be taken. Okay, so fine. So now if we see the picture of model based reflex agents. Okay, so let me first tell you what was there when we talked about simple reflex agent. So when we talked about simple reflex agent, okay, of course we were having environment, of course we were having agent, okay, of course we were having sensors, and of course we were having actuators. Okay, and sensors will always tell what is the world like now, because they are just responsible for percepting the current input, and the actuators have to decide what action they should do now, and that action will be given back to the environment. Okay, and then we were having condition action rules which help us to able to understand that what action has to be taken. So this was if we skip this part, okay, then except this part, okay, except this part, the everything remains same, and it was the working of simple reflex agent. But now what we see new is that after the agent has received the input via sensors, okay, then it has to decide its state. Okay, then it has to figure it out in which state it is, and to figure it out in which state it is, okay, there are certain more important things, and they are how the world evolves, what my actions do. Okay, so there will be another, let's say, a processing which will take place onto the input which we have currently received from the environment, and after this processing take place, it might happen that your input which is received from the environment, okay, may be updated with additional many informations, and then that input then will finally go to the condition action rules, and after it that it goes to the condition action rules, then finally it will be decided what action should happen. So students, the point here is that the percept which is received from the environment, the current input which is received from the environment, does not go as it is to the condition action rules. Okay, it is appended with many other things which actually in turn describes the internal state of the model based agent. Okay, and then what is it? Okay, so the input is modified by which parameters? The input is modified by the parameters how the world evolves, how the world evolves for the agent, the environment in which it is working, and what its actions are going to do. Okay, now what my actions will do, so how it can identify, how it can know that what its action going to do. So it has a history of percepts, so it will be easily able to understand that, okay, if certain things are like this, then my actions may result to something like this, because it has a history of percept, and a history of what actions were taken by it in this percepts is already known to this agent, and that's why it becomes easy for these agents to update its state and then pass this state or these modified input to the condition action rules, which in turn in a very simplified manner will tell, okay, if this is the condition, please take this action, and then these action will be given by the model based agents back to the environment. So students, this is how the model based reflex agents are going to work. Okay, again, if we see over here, they are going to have input, they are going to have output, they will have condition action rules, but the another important thing on which they work is the state, and the state is defined by how the world evolves and what their actions do. Okay, so that's why at times they are also known as reflex agents with state. Okay, because state is very important for them. Okay, so yes students, this is how the model based reflex agents look like. Okay, fine. Now, let's see what could be the function of model-based reflex agent. So I think we are well aware now of certain thing like this, because we already have seen an example of what a table-driven agent look like, and then we took an example of what a simple reflex agent look like. Okay, so if we see, it is very much similar. The function looks very much similar to simple reflex agent with certain more additional things into it. Okay, so the name of the function, let's say it's model based reflex agent, and of course it is receiving the input as percept. It will always receive only the current percept as input. Okay, and it has to return an action. Now what will be the things which will be fed into the system, okay, which is very important. Okay, so it will have a knowledge about state, okay, the agent's current conception of the world. So it has to store the knowledge about its state, okay, which means it will be storing information about the current scenario of the world. Okay, world, which means the environment in which it's working. It will also have something, let's say model stored into it. Now what is model? A description of how the next state depends on the current state and action. Okay, so it will have information about the model, and the model will help the agent to understand that how the next state is depending on to the current state and action. Okay, so as of now it is in current state, but how next state is depending on this state also. Then of course it will have rules, that is set of condition action rules. Okay, and of course it will have action, the most recent action, initially none. So until and unless the agent hasn't started working, the action will be none. Okay, so these were the things, which will be already stored into the agent. That will be the state, that will be the model and rules. Now state will keep on modifying. Why it will keep on modifying? Because as and when new percepts will be received, okay, depend using the model, okay, using the previous actions which it has already taken, okay, considering all these parameters, the state will change. Okay, so now students, in simple reflex agent, to interpret the input, only the percept was important. Okay, so if you remember that even in simple reflex agent we were having interpret input as a function in which only one parameter was going, that was just percept. Okay, in that only one parameter was going, that is percept, and then we were having the outcome as state. Okay, the rest part I think remains the same. But now over here, to interpret the input, only percept is not important. The percept is important. Okay, the model is very important, the state is important, and the action, if taken any, for the previous percept is important. Okay, because then it will able to understand that what my actions do. Okay, because if it has already knowledge about percept history, then it will be well aware about that in this state what it actions are going to do, whether they are going to perform well, whether they are not going to perform well, whether these actions needs to be taken, whether these actions needs not to be taken. So it will be well aware about that. And students, that's how it will be able to identify the state. So that is very important, because once that state is identified, okay, when we say state is identified, we are trying to say that whatever input we have received, okay, we are able to, let's say, modify that input now. Okay, initially we were just knowing what the world is like now, but then we have some additional things attached to it. Okay, what my actions will do if this is the state of the world. Okay, how the other things surrounding me are working. Okay, those all things will be appended to the current input, and then once they are appended, it becomes very easy for an agent to decide a particular rule, and from that particular rule to decide a particular action. So once the state is identified, okay, then it goes to the function which is known as rule match. Okay, it passes the current state and set of rules, okay, which will be defined again into the system depending on what is the work of that agent. And from that set of all the rules, okay, there will be one rule which will be matching this state, okay, which is just being derived. And once we find out that rule, then we have to go to, we can say, the condition action rules. Okay, and then we have to find out which action is relevant for this rule, and then that action will be executed by these actuators and given to the environment. Okay, so this is how the model based agents are going to work. Okay, again students, if we see the functioning of model based agent, it will receive input as percept. And then the details which will be stored into the model based agents are the state, the model which will have the description of to the on how the current state is depending on to the on how the next state is depending on the current state and the action, a set of rules, and of course a set of condition action rules also. And then the action, okay, action initially will be none, and depending on whatever actions are being taken by the agent, depending on the history of percept, these parameter can also grow. Okay, so of course there are, you know, if you see over here, you can find two action, one action which is returning and one action which is again a part of an input for this model based agent. So the action which is a part of an input for this model based agent is nothing but a certain action depending on to the previous history of percepts, okay, which can help the agent to identify how well now this time the action could be. So that's how action is a part of the working of the model based reflex agent, and as well as action is a part of being returning an output as well as from the model based reflex agent. So yes, students, these was the working of model based reflex agent. Okay, what we saw was that it works on a model, it works on a state. These two are very important things for the agent. When it has to decide its state, it should know how the world evolves and what it acts, what my actions do, what the agent's actions do. Okay, once these two things are known, the state will be identified. Once the state is identified, that state will be will be, we can say, appended with the current percept, and whole this thing will be able to identify another new state which will go into the rule match. A rule will be identified, and once that rule is identified, it will be known what action needs to be taken. So students, this was the working of what we call it as model based reflex agents. Fine. Going forward, the next kind of agent is goal based agents. Okay, so if we have understood model based agent, okay, the goal based agent is, we can say, one step ahead than this model based reflex agents. Okay, the working and everything is extremely similar to the model based agent with one additional characteristics. Okay, so let's see what it is. These kind of agents take decision based on how far they are currently from their goal. Okay, their every action is intended to reduce its distance from the goal. So students, over here you can understand that of course if we talk about model based agent or goal based agent, okay, they might be working in different scenarios. So let's say if it is just model based agent, okay, it has to do its work, and it has to do its work properly to increase its performance measure. And maybe the environment will be probably cooperative, because it has to just keep on, you know, take care of other things also, what it actions does, etc. But what we see over here is, when we talk about goal based agent, they are very much clear that they have certain goal and they have to achieve that also. So they will work exactly like model based agent, but every time they take action, they also have to decide that how much nearer they are there to their goal. Okay, so if you talk about, you know, a chess based agent, chess playing agent, then for the chess playing agent, it is very important, of course, it has to work on a model. It is not a simple reflex agent at all, because it has to work on a model. But yes, it also has to work towards the goal, which may not be the case for a taxi driving agent. Okay, maybe the goal will not be very important when it comes to a taxi driving agent. Okay, but yeah, following the model continuously until and unless the end result is not acquired, that is fine. But when we talk about goal based agent, every action should be such that, okay, that the agent is nearer to the goal. So now, what one thing will differ over here is, these allows the agent a way to choose among multiple possibilities, selecting the one which reaches a goal state. Okay, so it might happen, students, over here, that a student, that an agent may have, you know, multiple possibilities, which means, let's say, multiple, let's say, rules possible for a current state, or multiple actions possible for a current rule. And then it has to decide, okay, whether it has to go for this or this. So that will differ into the goal based agent. The knowledge that supports its decision is represented explicitly and can be modified, which makes these agents more flexible. So very important point that comes over here is that the knowledge base of these goal based agents can keep on modifying. Okay, so it may happen that everything will not be very static into the goal based agent. Okay, the things will be flexible, the things will be dynamic, which means the goal based agents initially will be given certain knowledge. Okay, of course they will start their working on their knowledge. Now once they move ahead into their journey of working, they will start receiving more and more information from the environment on how they are working. What they will do is they will keep on updating their knowledge base from all these things. And then what they will do, because see, if they are not going to modify the knowledge, then they cannot have multiple options to choose, because initially everything will be fixed, that if this is there then this needs to be taken, if this is there then this needs to be taken. So those things will be fixed initially. The knowledge base has to grow, then only it is possible that they can identify, yes, there are multiple opportunities possible, there are multiple actions possible when the percept is like this. So then what they will see is, okay, when I have taken these action, what has happened to me? Was I near to my goal, or was I not near to my goal? And for similar percept, there is one more action also possible. Fine, so which should I take? Should I take action number 1 or action number 2? And that will make them very flexible, and then depending on that they can change their behavior, which means they can change their action. Yes, but to do this, to identify this, they will require planning. So there are very well planned algorithms which work on these kind of agents, and after planning, once they decide that they have to do like this, they have to do searching from number of possibilities which are available for these kind of agents. So students, now if we see how they work, like, okay, then what you see is whole scenario remains the same, but what you see is that state, how the world evolves and what actions do continuously gets appended into the current percept. And then certain we can say input is decided from the current input, that what it will be like if I do action A. Okay, so what they do is they receive the current input, and then before actually passing the real action to the environment, okay, so before the action actually go to the environment, they figure it out n number of possibilities of action which could be possible. Okay, whether to give action number 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. Okay, now they have all these actions, and then what they do is then they start mapping their actions to the goals. Okay, so they will have a goal or a multiple goal defined, they start putting matching their actions. Okay, if I do action number 1, whether it is going to match my goal. Oh, no, then let me see about action number 2, whether it will help to match me my goal. No. Yeah, action number 3, yes, it is helping to match my goal. Okay, fine, let's go ahead with that and give that action to the environment. So students, here what we see is that the goal plays very important role, and depending on that the action will be taken. So of course model is there, because when we say that the input is modified with state, how world evolves, what my actions do, model is definitely there. But here the model is flexible enough to give you multiple possible actions which can be there, and depending on that the agent will take a particular we can say action and give it back to the environment. So probably if you could think about all the game playing agents, they will all be into the goal based agent. Okay, take a very simple scenario about a tic-tac-toe playing agent, because why I'm telling you tic-tac-toe, because you can visualize it very easily, the environment will be very less. Think about for us as an agent, if we are playing tic-tac-toe, and if you can do an analogy, students, we exactly were in the same scenario. And if you could understand this, then that is the exact coding, or that is the exact application or logic we have to really put also when we start making these kind of agent. Okay, so here again students, if we talk about goal based agents, okay, they are very much clear that their every action should be nearer to the goal. to do that, they require planning, they require searching, and what they will do is every time they will come up with multiple possibilities of action, and whichever action is very much nearer to the goal, they are going to use it and give it back to the environment. So this is how the goal based agents work like. Okay, fine. Moving forward, okay, the next one are utility based agents. Okay, so now first of all here we have to understand when we say utility, what exactly we are trying to say. Okay, so we know that when we say utility, our focus is more on what we call it as service, or a certain, we can say, preference, something like that. Okay, so that's how the working of these agents is. Okay, so first of all we have to identify that which kind of agent can belong to utility based agent. So let's say, students, if we start from again model based reflex agent, so what we saw, taxi driving agent can be very well fitted into that, and into model based reflex agent. Okay, if we talk about let's say goal based agents, all maybe the game playing agents very well fit into their environment. So now what could be utility based agent? Okay, where in a scenario we will be more giving emphasis on service. Okay, so of course we can understand over here that if again we are talking about utility based agent, then model is going to be a part of it. Okay, because without model we can never understand whether the agent or the user is satisfied in this state or not, or is actually getting the utility which it really needs. So it will work on model based agent, but one additional parameter. Okay, that we call it as utility. Now what exactly utility means? Okay, that how happy we are in this state. Okay, whether what exactly we demanded from the agent, whether we have got that or not. Okay, so that's what is important over here. So if we try to understand, and if we take an example of something known as, let's say, internet shopping agent. Okay, so that is something which can fit into this scenario. Okay, or let's say we talk about an agent which helps us for guiding our whole travel. So let's say if you want to travel to these many places, maybe, and then you give budgets, and maybe you give your preferences. Okay, so I'm using the word preferences. So probably wherever in a scenario you have to give preference to agents. Okay, which is not a mandatory part of model based agent. Okay, when you talk about model based agent, there is nothing like preference. Okay, that is the work which has to be done, and that has to be achieved. Okay, but even when you talk about goal, there is nothing like preference. Okay, you have to reach near to the goal. But now when you talk about utility, you are telling about certain preferences. Okay, you are not worried about goal. Okay, you are not worried about whether that thing is achieved or not, but you are worried about, or the agent has to take care about the preference, whether it is working in suitable need to the user or not. So that's why when utility based agents are there are multiple scenarios. Okay, these agents are complicated in the sense that every user may have different set of preferences for these kind of agents. Okay, so I just gave you a background. Okay, let's read about it and understand what exactly it tries to tell us. These agents, which are developed having their end users as building blocks, are called utility based agents. Okay, so what are the building blocks for this agent? Their end users, the users who are actually going to use this agent will actually define how these agents are going to grow. When there are multiple possible alternatives, then to decide which one is best, utility based agents are used. Okay, which one is not nearer to the goal, but which one is best. They choose actions based on a preference for each state. Sometimes achieving the desired goal is not enough. Okay, so they are just not worried about achieving the goal, but they are more worried about the preferences. So at times we may look for a quicker, safer, cheaper trip to reach a destination. Agent happiness should be taken into consideration. Okay, so now agent happiness, which means the agent which is working with utility based agent. So here we are talking about a human agent interacting with a utility based agent. So the utility based agent has to consider the satisfaction and the happiness of the agent who is interacting with it. Utility describes how happy the agent is. Because of uncertainty in the world, a utility agent chooses the action that maximizes the expected utility. Very important point, students. See, utility based agents will never be able to understand. See, for some human, for some person, okay, getting a safe trip is very important. For some person, cheapness will be important. For some person, okay, to reach there in one day will be important. So there will be whole lot of different expectations from many different people who are interacting with these kind of agents. Even if you start thinking about the shopping agent, okay, you can understand how versatile it will be. Okay, if you even just take, the parameter of 100 input or 100 different users interacting with that utility based agent, most of them, everybody will be having their different environment, so sorry, different expectation. So it becomes very difficult for these agents to decide, because the uncertainty of the world in which it is actually executing is very difficult. But still, in that case, what it does is it tries to choose the action which maximizes the expected utility. Now, a utility function maps a state onto a real number which describes the associated degree of happiness. So now how these utility based agents will be able to decide that, okay, this is the action which I have to take. So what will be there? There will be a utility function which will be fitted into the system, and that will, come out with certain number depending on a certain action. So what will happen, that, okay, if this is the action, it will say the degree of happiness is low. If this is the action, the degree of happiness is high, depending on to the agent, depending on to the preferences of agent, and also depending, a very important part over here is depending on to the history of agents behavior with this utility based agent. So these whole things will be able to identify how these utility based agents are going to work. So what we see, if we see again that everything remains the same, but yes, one more thing is added over here, is that how happy I will be in such a state. Okay, so it will take the input, okay, then it will find out the state depending on several parameters like state, how the world evolves, what my actions will do. Okay, then it will also have, so if you see utility based agents, okay, are also working as goal based agents, because they decide from multiple actions which action need to be taken. But still it goes more further one step. After even deciding what action they have to take, they decide how much happiness will be there in this state. Okay, and then that thing is being continuously mapped with the utility. Okay, what is the utility? What is the agent's happiness? Utility means what is the agent preference? Is the agent preference to have discount on the products, or is the agent's preference to have only products of this brand, or is the agent's preference to have only the t-shirts of this color? What is the agent's preference? Okay, and then depending on that agent preference, they come up with a state which they term it as happy state, depending on the degree of value that they get. Okay, and then after these things are decided, okay, they take an action and throw back to the environment. And of course you can understand that this whole process keeps on revolving again and again. And every time, once they get certain input from the environment, so every time, these kind of agents also take feedback from the agents which are using it. Okay, they take input from the environment, they take feedback from the environment, and start updating their utility and their happiness state. So they keep on growing, and they keep on understanding more and more perspectives on how they interact with the agents. So students, this is how the utility based agents work like. Okay, so what we saw is that initially we started with model based agent, and we understood how the world evolves, how the actions play an important role to decide the action. Only the current percept is not important. Moving forward, we decide that even after we come to know what action we have to take, there are multiple possibilities of action for this current state also. Okay, from that, which best action needs to be taken so that the goal is nearer. And going forward, we again decided that, again taking that action, how it is very important to know that whether the user satisfaction is there or not with this agent. So this is how all the different types of agents will work. Okay, utility based agent will have their own users, will have their own environments. Okay, so goal based agents will have their own users, they will their own environments, and they will fit exactly where their purpose is there. Okay, so it is nothing like that, that goal based agents is good and utility based agent is more better than that. No, it is nothing like that. It whole and solely depends upon the kind of agent it we need to design. So if the purpose of designing is our agent is about utility, then of course the utility based agent model has to be uh, gone through, and we have to make our model in accordance with that, and that will also go for the remaining type of agents. Okay, fine. So that was for today's session, students. Okay, thank you all of you, thank you.